Bismillahirrahmanirrahim. I begin by praising Allah, the most beneficent, the most merciful. Assalamualaikum. Assalamualaikum and a very, very good morning. Dengar tak suara saya?
Dengar, Doktor.
Dengar, Doktor.
Clear eh? Sebab kadang-kadang dia tak dengar kan? Itu yang saya tanya. Okay. Nampak kan skrin kan? Kalau boleh bukakan gambar video kejap-kejap buka tutup pun tak apa. Saya perlukan manusia di depan saya. Okay? Kalau yang dah bersedia lah, kalau yang tak bersedia tak buka tak apa. So today, based on the video that we watched just now, we're going to continue regarding the components inside the machine, inside the UV visible spectrophotometer. Okay, and hopefully we'll finish the topic today and we continue next topic tomorrow. There are 4 to 5 components if we look at the video just now. Okay. Here we can see we have the light source. Everybody can see the screen, the slide on the screen. The light source, and it will go to this monochromator where the light will be dispersed and then will be selected. So dispersed into several wavelengths of light, and only the light that want to be used will be selected. Normally just one wavelength of light, 1 nanometer. 204, for example, 205. They cannot choose 204 up until 206. No, not in the case of measuring the concentration. Okay? And then the light will come out, the monochrome light will come out here. And the sample will be somewhere here. The one that we see in just now, okay, the first video showed us the split UV vis. Okay? Remember in the questions that have been asked just now, we have 3 types of spectrophotometer. The first one is a single cell, and then the double, and then the split. Okay? So this one is single cell. In single cell, we have the problem with single cell is we have to put the reference, take out the reference and put the sample in. Okay, if we have split or we have double, we put the sample and then we put the reference next to it or in the cuvette next to it, and then we just leave it like that. We don't have to remove anything. We do not have to open the lid too often or too often. Okay? And then finally, this is the detector. Okay? It changes the translucent value to electric, and then it will give numbers on the screen. Okay, we go to the first compartment. The first thing that we need to learn is the light source. Okay? Normally, we have to remember 2 sources. The first one is the deuterium, the first one is, we go for deuterium first. The first one is deuterium, the second one is tungsten. But for deuterium, sometimes they use the term hydrogen, the same thing, the same equipment, the same machine. Okay, this. And it will provide the UV spectrum light, okay? The light that we can't see. And for this one, for the second point there, okay, sometimes we find different numbers here, okay? But if we have 2, for the first one is UV and the second one is the visible. UV is normally lower than visible. For example, here it gives from 150 up until 370. So the visible will be 370 something up until 800. Okay? But sometimes it says from 150 until 250, 150 up until 350, still okay. Okay? if the question comes out, what is it that we need to answer? Okay, if they are MCQ, then the question is, the answer will be there. But if it's structure, so you can put any value, either it's 370 or 250 or 300, all are acceptable. Okay, don't worry. Okay, and then the mechanism is, this is the one that we've covered in the earlier lecture. Means that when the light is being shown to the sample, and that the element inside the sample have to absorb it and have to react, have to excite, then we can see it, then it can be detected. Okay, and in this case, it's not atom, it's molecule. For UV, it's molecule. Okay, this is the deuterium lamp. Maybe it looks like this at some point, okay? But maybe it doesn't look like this. This is just an illustration, just like the picture of Big Mac in McDonald's. They don't look the same, isn't it? You see it on the billboard, very nice, big and moist and bulky. But when you buy it, it comes in thinner form. Yeah, so this is just an illustration purpose only. Okay. Again, this is the picture of it. Macam lampu kereta. It looks like a bulb in the car's headlight. The second light source is the tungsten. Okay, normal bulb, mentor biasa. Okay, light for tungsten, it will produce the light source in the range of 350 or 400 up until 1000, you mentioned just now. But we only want it to be until 800 because the rainbow light lies within there, okay, between 300 or 350 up until 800. All the 7 or 8 different colors. 7 or 8, ada berapa sekarang? How many colors are in the rainbow?
7.
7, eh? Okay, very good. Ada yang kata dah 8. Okay, so this is science. Science changes. Okay, these are some extra information. There are some of the lights, some of the lamps that can be used in order to produce this either UV or visible source of light. Okay, there are some of them are LED, the new ones at the moment, but they are not very bright. Or xenon arc light. This is a good light, but quite expensive. Normally, in a normal spectrophotometer, normal UV visible spectrophotometer, they will use either, not either, they will, if it's UV visible, it will use both deuterium and also the tungsten. Okay? The second part, the monochromator. What it does is just it will reduce the polychromatic source or input, and it will release out, the output will be a monochromatic light. One wavelength of light only. Okay? Itu cara dia. Macam cara dia buat. Okay? You know, sometimes it's good if we can remember this. The component inside the monochromator. Okay? What kind of question? This is sometimes just true and false. Okay? True and false. Or matching. But true and false are more suitable for this one. Because, you know, we can change one word, we can add another word, and then it will be true or it will be false at some point. So please remember that. Okay, this is how it works. We have seen the video just now. It said the same thing. Okay, same thing. I want to go on to the next compartment. Okay, that is the second part. The first one is